Let's say, hypothetically, a nuclear bomb just went off 3 miles away from you. Your instinct says run. Your legs say run. Physics says sit down. Today we are doing something deeply irresponsible. The math on whether any human being, any vehicle, or any fictional speedster in a red suit can outrun a nuclear explosion. First, let's understand what you're running from. Because a nuclear explosion, it's not one thing, it's several things, and they are all deeply, deeply uninterested in your survival. A nuclear explosion isn't just a big bang, it's a cascade, a sequence of killers arriving one after another, each one worse than you'd expect. First comes the thermal radiation, the light, the heat. It travels at the speed of light, 300,000 kilometers per second. You know how fast Usain Bolt runs? 10 meters per second. Usain Bolt, the fastest human who has ever lived versus the speed of light. I'm not even going to do that math. It would be disrespectful to mathematics. The thermal flash from a 1 megaton bomb, which is the standard we're using today, gives you third-degree burns at 10 kilometers away, before you have even registered that something happened, because the light hits your skin before the image hits your eye. Then comes the shock wave, the blast wave. This is the one you see in movies, the invisible wall that flips cars and levels buildings. It travels at supersonic speed, initially over 750 miles per hour. To put that in perspective, Usain Bolt, 27 miles per hour. A Bugatti Chiron, the fastest production car on Earth, about 300 miles per hour. The blast wave, 750 miles per hour, and climbing. A 1 megaton blast wave covers 10 kilometers in roughly 30 seconds. In that same 30 seconds, a sprinting human covers about 300 meters.
Right there, you're dead in 2 seconds.
And then there's fallout. Radioactive particles, vaporized dirt and debris sucked into the atmosphere and carried by the wind. Here's the thing about fallout. It's the slow one. It travels at wind speed, normal wind speed, which means this is the one you can maybe beat. First, let me bring in some competitors. Competitor 1, Usain Bolt, the fastest human, 10 meters per second, against a blast wave doing over 300 meters per second. Usain Bolt would be fine, because Usain Bolt is smart and would be nowhere near a nuclear explosion. But hypothetically, he's gone in seconds. The blast wave catches him before he takes his third stride. Competitor 2, a sports car. What if you're in a car, even a fast one, say a Ferrari, doing 200 miles per hour on a completely clear road with no traffic? The blast wave is doing 750 miles per hour. The car gets overtaken, flipped, and turned into a missile, with you inside it, aimed at whatever's in front of you. So now, instead of dying from the blast, you're dying as the blast. You've become a projectile. Congratulations, I guess. Competitor 3, a military jet. Now we're talking. A supersonic jet, say an F-22, can exceed Mach 2. That's about 1,500 miles per hour. The blast wave moves at Mach 1 to Mach 5 near ground zero. Mach 5 is 3,800 miles per hour. The jet loses too, unless the pilot was already far enough away and flying away from the detonation at full afterburner the moment it went off. Then maybe they extend their lead. Competitor 4, the Flash. The man who runs so fast, he bends time. In the films, the Flash has been clocked, unofficially based on the events depicted, at somewhere between Mach 10 and Mach 13,000. Some calculations put him at moving faster than light itself. So, can the Flash outrun a nuclear explosion? Yes, obviously. He literally outruns time. He could run back in time and stop the bomb from being built. This is a man who once vibrated through a building. The blast wave is not the issue. The Flash's real problem is that nobody told him about the thermal radiation, the light, which also travels at the speed of light. Depending on your interpretation of his powers, the Flash and the thermal Flash are moving at roughly the same speed, which means if he's standing at ground zero when it goes off, it's a tie. And in a tie with a nuclear explosion, the nuclear explosion wins. However, and this is important, if the Flash has even a half-second head start, he's in another country before the photons leave the fireball. Okay, here's the part of the video that actually matters. If running doesn't work, and it doesn't, what does? The answer is counterintuitive, embarrassingly simple, and yet it's backed by actual survivor data from Hiroshima and Nagasaki. Step 1, drop. If you see a flash, any unexplained massive flash, do not look at it. Drop immediately. Face down, hands under your body. Why? Because the thermal radiation travels faster than the shockwave. If you drop the moment you see it, you've already avoided the worst of the heat on your skin and eyes. The ground absorbs some of it. A shadow reduces burn injury. This is not a joke. In Hiroshima, people who were inside reinforced concrete buildings at 2 kilometers survived. People out in the open at 4 kilometers did not. The building didn't stop the bomb. It just got in the way of the energy. That was enough. Step 2. Take cover behind anything. A wall, a ditch, a parked car, anything. Most of the deaths at survivable distances in Hiroshima and Nagasaki weren't from the blast pressure itself. They were from shattered glass and flying debris. Any cover that keeps projectiles off you dramatically improves your odds. Step 3. The fallout game. Go inside, stay inside. If you survived the blast, you now have a new enemy, fallout, primarily within the first 24 to 48 hours. This one is actually beatable. FEMA's official guidance is 3 words. Get inside, stay tuned. A solid building, ideally with thick walls, ideally underground or in inner rooms, reduces your radiation dose by over 90%. So the one thing you can outrun, the fallout, you're better off not running from. Go inside. Wait 12 to 24 hours. You know, there is something quietly profound about that. In the face of the most destructive weapon humans have ever created, the answer isn't speed, it's stillness. It's getting low. It's using the earth itself as your shield. The explosion doesn't chase you. It expands in all directions at once, faster than anything you can drive or run. The question was never, can you outrun it? The real question is, were you already far enough away? And if you were, the thing that saves you isn't your speed. It's knowing what to do in the next 10 seconds. And if you've watched all this long, I'm sure you'll like this one. See you there.